Good morning, good afternoon, good evening. I'm not sure exactly what time you're seeing this, but good at that time, whatever you happen to be watching this. Yay! Alright, so we're going to talk about the Pythagorean Theorem. Today you will use the Pythagorean Theorem and its converse, and you will discuss and find ways to say find a missing side, or also use it to find what type of triangle it is. So what is the Pythagorean Theorem? The Pythagorean Theorem is something you've seen before. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared equals c squared. You've seen this plenty of times before. You should have already seen this in middle school. Let's just make sure we understand. A and b are what are called the legs. In other words, the shorter sides of the right triangle. And c is the hypotenuse, the side that is always going to be opposite the 90 degrees. Keep that in mind. Okay, and we kind of go from there. So let's look at an example. So here I'm going to give you two examples. On the first example, if you notice, we're looking for, on the one on the left, we're looking for, well, obviously we're looking for the x. But we're this case, that's the hypotenuse. So that means 6 is A and 15 is B. It really doesn't matter which one you say is A or B. Just recognize that they are the legs, and no matter what, the x or what one you're looking for is c, because that way you know you put the numbers in the right spot. You're going to say 6 squared plus 15 squared equals c squared. You would type that in your calculator if you like, and you would get 6 squared plus 15 squared is 261. Then you can go ahead and take the square root, and again, don't forget how we take the square root on the calculator by pressing Control X2. So square root of 261, and you would give me a decimal answer of about 16.15. That's when we put the little curvy equal sign to represent that we're estimating. We're rounding off. Okay, and that's fine. Later on, we will discuss how you can simplify the radicals and the importance of that. But you can kind of go from there. Now, if you look at the other example, I'm missing the 11 there is a C. So that means basically I can say that's A and that's side B, and I can go x squared plus 9 squared equals 11 squared. So how am I going to solve this? Well, basically I'm going to subtract the 9 from the 11 squared minus the 9 squared. Now keep in mind, you're going to do those squares. I would type all that into the calculator as is, straightforward. 11 squared minus 9 squared is going to give you 40. Then you can take the square root like that, and then you would get approximately 6.32. And that's really about as complicated as that gets. Now, I do want to mention there is this thing called a Pythagorean triple. Pythagorean triples are a set of non-zero whole numbers such that a squared plus b squared is equal to c squared. In other words, they're basically no decimal answers with these. and see, most of the time when you do Pythagorean theorem, you're going to get decimal answers. But there's some that work out specially. Now, the most common one that you've seen since, like, with your star exams and stuff like that, has been 3, 4, and 5. And any combination of that, like 3 times 2 is 6, 6 times 2, or 4 times 2 is 8, and 5 times 2 is 10. So 6, 8, 10 is also a Pythagorean triple. It would be a right triangle. You multiply the 3, 4, and 5 by 3, you'd get 9, 12, and 15. So again, there's another Pythagorean triple. 9 squared plus 12 squared equals 15 squared. Anything that multiplies by 3, 4, and 5 would give you a Pythagorean triple. Another example is 5, 12, and 13. There's another Pythagorean triple. Again, 5 squared plus 12 squared is going to be 169. 13 squared is 169. Anything when you multiply those by 2 or by 3, you would still get another set of Pythagorean triples. Next one would be, say, 8, 15, and 17. And you can see multiples of that. And then 7, 24, and 25, multiples of that. Those are some of the most common Pythagorean triples. Keep in mind, like, I guess if you want to say the ones on top, those are like your base ones. All the ones below are multiples of those, like multiplying by 2 or multiplying by 3, like all the sides. So you kind of see how that works. Now, all that does is just to kind of make things faster for you. It would be great if you could memorize these, but it's something that would make things faster. How do you ask? How does it make it faster? Well, let's see here. Here's a Pythagorean triple. First off, you had this in your notes. or in your note sheet, you'd already know the answer because you can tell it's 9. But let's think. Well, if I divide, let's say, well, I have a common Pythagorean triple 3, 4, 5. If I divide the 15 by 5, I get 3. If I divide the 12 by 4, I get 3. So basically, they multiplied the 4 and the 5 by 3. So that means then I can go multiply the 3 by 3 and get 9. So the missing side has to be 9. And you can check that by saying 9 squared plus 12 squared and see if it equals 15 squared, which it does. So there you go. Like I said, it's just something that if you have certain things memorized, it would make things faster, quicker. That's about it. But it's just something there for y'all to know, and know that there are some special properties with Pythagorean triples. Okay, so now let's look at the converse of the Pythagorean theorem. The converse says that if a squared plus b squared equals c squared, then the triangle is a right triangle. So basically, now we're assuming that first that we had a right triangle, and that because it's a right triangle, a squared plus b squared equals c squared. Now we're saying that, okay, we're just given 3 sets of numbers. We want to make sure it's a triangle, and then we want to see if it can be a right triangle. Keep in mind, a and b are always the shorter sides, and c is always the longest side, as you're comparing. Also, we can throw in this and say the Pythagorean inequality theorems, which also says that if a squared plus b squared is bigger than c squared, greater, then ABC, the triangle is acute. If a squared plus b squared is less than c squared, the triangle is obtuse. Okay? So, example. Let me give you 7, 14, 16. Okay, so we're going to see about 7 squared plus 14 squared and compare it to 16 squared. But before we do that, we want to make sure that this could be a triangle. So 7 plus 14 is 21, and we know 21 is bigger than 16. So yes, this could be a triangle, just like what we did in the last test. Now, 7 squared plus 14 squared is 245. 16 squared is 256. So 245 is less than 256. Since it is less, right here, as we're seeing here, when it is less, we would say it's obtuse. So this is an obtuse triangle. Those 3 sides together would make an obtuse triangle. Let's look at another example. 9, 40, 41. Okay, again, 9 plus 40 is 49, which is greater than 41, so yes, it could be a triangle. 9 squared plus 40 squared is equal to, or I'm sorry, not equal to, but 9 squared plus 40 squared, and we're going to compare that to 41 squared. 9 squared plus 40 squared is 1,681. 41 squared is 1,681, which they're equal. Since they're equal, we would say this is a right triangle. That's really about it. I'm not going to go further into detail with that. I will answer any questions you have next time I see you. But, you know, like I said, this one hopefully should be something simple, should be kind of easy, just kind of use the formulas. Anyways, that's it for today. Thank you so much for your time. I really do appreciate it. Y'all take care. And let's throw in a magic word for, say, the next test. What should our magic word be? Let's go with amulet. If you can give me the word amulet, then that would be written on top of your notes. I'll add extra points on your next test. Thank you so much. Y'all take care.